Michelle.
Thank you, Corinne. So again, welcome everyone. We're going to be talking about connecting to geospatial data. And what I've taken this content from is the AutoCAD Civil 3D for Surveyors course. And this is actually Chapter 2. So it's something that I've added recently to this course. And so it's exciting to be able to share this information. Let's make sure we can go to the next slide here. There we go. So again, this is Chapter 2 of the Civil 3D for Surveyors course, and we're going to talk a little bit about the planning and analysis workspace because we are going to be using a lot of those functions today to be able to do this. We'll set the coordinate system of our file, work with some geospatial data and connect to it, and then create a surface from that geospatial data. So first off, we want to identify where tools are found within the planning and analysis workspace. Now, basically, those of you that have AutoCAD Civil 3D, you also have all of the capabilities of Map 3D within the software, and you access those commands through the planning and analysis workspace. So what I'm going to do, just really quick, is switch over to the software and show you where to find that, how to switch over to it, and then just introduce you very quickly to a couple of the commands that are available. So when I want to go from the Civil 3D tools to the Map 3D tools, I go to the Workspace Switching tool that's on our Quick Access toolbar and select Planning and Analysis from that. This is going to invoke a number of different tabs or ribbons at the top. So our Home tab, you'll notice, looks slightly different than the Home tab that we have for Civil 3D because it has the addition of the data panel where we're going to be able to connect or attach GIS data. Now the difference between these two, if I attach data, that line work is going to convert from whatever its original format was into a DWG format, and so it becomes vectors physically in the model. And the difference with the connect is that the connect acts a lot more like an XREF. So we're going to reference geospatial data rather than bring it in physically. Now, you can see in my screen, I actually have a GIS data, which is basically our parcel data, connected in this drawing. And when I hover over something, it acts like it's part of the model because it is connected. And the nice thing about this is because I am connected, I can actually make edits to that data right from the Civil 3D workspace or right from AutoCAD, and it's going to go back to its original format. So if let's say I come in and I subdivide this parcel at the top, it's going to make that change in the original file, even if that original file is an ArcSDE file or a shape file or something else. And so you want to make sure that you're communicating with the GIS department that maintains that data, what changes you're making, so that they don't go in and say, oh my goodness, something changed and I wasn't aware of this. So again, it's a communication thing. But a lot of the tools, like I said, we're going to work with the data panel and connect. Now the other part of it is we're going to work with the map setup tools because this is where we're going to go and set things up the way we want them. So we're going to make sure we assign a coordinate system, we're going to attach data to our map, we're going to define classes and stuff like that. But we do have a full-on course on Map 3D that goes through many of these tools, so I won't get into too much of that. All right, so a little bit about the map workflow. What we're going to do is we're going to start a brand new drawing and make sure that we start it using a template that we would normally use in Civil 3D. So because we want to make sure we have all of the styles that we need when we start working with Civil 3D data. So we want to make sure we have our alignment styles and surface styles and so on. The next thing we want to do is assign a coordinate system. Now the reason that this is so important is because when we get data from other departments, or let's say we go to the municipality or the city that we're working in, that the project is going to be in, and we say, hey, can we get the parcel data for this area, and can we get the existing road center lines for this area? They can provide that information to us, but it may not be in the same coordinate system that our surveyors are going to use to go out and collect the project information so that we can engineer what we need to. And so if we are using a different coordinate system, we need to make sure that our drawing file is assigned a coordinate system, and the information that we got from the city also has a coordinate system, because then the software will automatically reproject that information together. Next thing, third step, is to actually attach our digital elevation models and our image files. These are our raster files. And the reason we want that is so that we can start planning our project. We can be talking to the surveyors and say, this is where we're going to be working on the project, and these are about the elevations that you'll be working in. In some states it's not that big of a deal because, something like Kansas, most of the elevations are within maybe 100, 200 feet of each other. Here in Utah, however, it becomes a very big deal because, they might need to dress for the conditions. Yesterday here in Utah, we received snow. The mountains received it, but right where I'm at in the valley, we didn't receive snow. So it's always interesting to make sure we plan our project properly. Next, we'll attach other source data, like our road center lines. If we have utility data that we can bring in, pipes that are already existing, manholes, stuff like that, we'll go ahead and attach that information and make sure that we have a database behind it so that we can go in and ask the software questions about that data when we get into analyzing it. Now, number 5, we're actually going to create a surface from from our source data. So it could be from our digital elevation models, it could be from a shape file, it could be from a number of different file types. But we want to make sure that we take advantage of that so that when we go in and start creating alignments, we can actually create a profile before our survey is even done. It makes it really nice to be proactive. Then we're going to go in and stylize the layers, where we're going to make things look the way we want them to look. We're so used to being able to do that automatically within Civil 3D, but when we use map commands, things come in automatically, and they might come in different every time you bring them in, and so we want to make sure that we force them to look the way we want them to look, and I'm going to show you how to do that today. And then, of course, we would analyze the data. This becomes so huge when we're talking about reducing the budget of a project. Let's say I have a project that I need to minimize the cost of building roads, and so I can actually go and attach a GIS data coverage of our road center lines and then also our parcels, and I can perform a query right in the software to say, hey, show me all of the parcels that are within 100 feet of a road that is a major arterial road. And that way, we can make sure that we only have to create a small segment of road to get into the site and then start building whatever our project is from there. So that analysis really helps you reduce the cost of your projects in the planning phase. And then, of course, if we have stylized our drawings, we want to make sure that we create labels and legends, and it would be slightly different in using the Map 3D commands than what we would normally use for Civil 3D. So you have all of those to think about. So let's actually, first off, let me show you how to go in and assign the coordinate system, and I'm going to show you how to do that in a couple of different ways. So let me go into the software again. And what I'm going to do is I'm going to create a brand new file. Again, I want to make sure that I use a template file to start my drawings from that is going to have all my styles already in it. So I'm going to use the one that's out of the box, that's our Civil 3D Imperial style, based on the National CAD standards, and I'm going to open it. And now that that is open, I'm going to assume that you're all starting from the Civil 3D workspace. If you did, you can assign your coordinate system right from this workspace. You don't have to move over to the Map 3D tool space to be able to use the option to set the coordinate system. And some of you may already be familiar with this option, but in the tool space, if I go to the Settings tab, I can right-click on the drawing name and then choose Edit Drawing Settings. And unfortunately, that came up on my other window. Let me pull it down. There we go. Now, the very first tab is the Units and Zone tab, and so you'll notice that when I use the drop-down menu for my categories, I have categories for everywhere around the world, from Afghanistan to Canada to Colombia, Japan, everywhere. In fact, in the United States, every state is listed because each of these areas will have different coordinate systems. And in fact, if I were to choose Utah, just in the state of Utah, we have a number of different coordinate systems. But we're working on this project in California, so I'm going to grab California. And then you can see I have a number of different coordinate systems just in the state of Utah. And so I want to make sure that I grab the right coordinate system. And I happen to be working in NAT 83 coordinates, and I want to use Zone 6. So I'm going to choose that with US feet. If you're constantly working in the same area, you're always let's say you're always working in the state of Utah in the Salt Lake Valley. Well, that would be the central zone. And so if I know that I'm always going to be working in the Salt Lake Valley, I can memorize that code, and I could have typed the code in right here and not had to go searching through the categories and then the coordinate systems after that. So I'll click OK, and that's how you can set the coordinate system. Now, if you wanted to start out in the Planning and Analysis workspace, you could have done the exact same thing. In the Planning and Analysis workspace, I would go to the Map Setup tab, and then on the Coordinate System panel, I would choose Assign. One thing you'll notice, though, since I already assigned it through the Civil 3D tool space, it's listed right at the top. So I can do it in either location. The key is make sure that you assign that one way or another. Okay? All right. Now, of course, the reason it's so very important is because if we don't set that coordinate system and we bring our data in, we're going to have to manually set the scale, set the insertion point, set the rotation value, and we want to make sure that we don't have to do that work. We can see actually here how projection systems work. It actually accommodates the curvature of the Earth, and we can see 3 different coordinate systems. And that central point, you can see it's 100% accurate at the central point, but as you get further and further away from that central point, you can see the distortion happen. And so we want to make sure that we're using coordinate systems, of course, that mitigate that and minimize the distortion values. So I already showed you this. Let me go ahead and jump past this part. Apologize. All right, so the next part is to display the current conditions by connecting to GIS data. And so this is where we're going to start connecting to the data, bringing in that GIS data. Now, we can do this in a couple of different locations again. So the first one, of course, is we can start out in the Planning and Analysis workspace on that by connecting on the Data tab. Or we can actually turn on our map tool space within the Civil 3D workspace. And we would do that by expanding the palettes panel and then selecting the map option. Let me just highlight this for you. So we would expand palettes down here. And this is our map tool space that's available within the Civil 3D environment. Now, as soon as you hit that button, it's going to act like nothing even happened. So what I would suggest doing is move your cursor into the model area of the drawing, and that's going to allow you to see that you need to either turn that map tool space on or turn it off. But once it's turned on in the map tool space, you would click Connect on the Display Manager tab, and then Connect to Data. When you connect to data, you'll receive this dialog box that allows you to connect to data, and you can see there's a number of different data types that are available. And so you can connect with ArcSDE, you can connect with enterprise industry models, SDF files, shape files, Oracle databases. There's a number of different file types that you can connect to. Now, if you already have some DEM data, so digital elevation models, DEMs are typically in a raster format, and so you would actually use the option to add raster image or surface connection, and that's where you would connect the DEM files. You'd also connect your aerial photos at the same place. Okay? Of course, like I said, once it's connected, we want to stylize that GIS data. If we were bringing in point features, let's say we had our utility data, we could actually tell the utility data, if you're a manhole, go ahead and look like a manhole symbol. Assign it a block symbol automatically according to the type of data that it is. If you're a fire hydrant, go ahead and assume the fire hydrant block symbol. So you can actually tell it how to stylize that data. If it's linear features like roadway center lines or pipes, you can actually define the line type as well as the line width and color. And then if it's an area feature type, you can tell it to hatchet a certain pattern. It can be a solid fill or some other type of fill pattern. And you can set the outline of that area by defining the line type, the line weight, as well as the color for that. So let's actually take a look at this in the software and see how that works out. All right. So again, all I've done, I've started a drawing, I've assigned the coordinate system. Now I'm ready to connect to the data. You can see that because I've in the planning and analysis workspace, my map task pane is already displayed, so I can use the data connect from here. I could also use it from the data panel and click connect. And then, of course, if I was in my Civil 3D environment or Civil 3D workspace, I could expand palettes and tell it to turn on that map workspace. Now, again, it looks like nothing happened, so I'm going to move my cursor over into the model area and just click on so that it turns that map task pane on. Now I can connect to my data. Does that appear somewhere else? Let me pull it down. So I happen to have a raster image that I'm going to go ahead and connect to. I don't have a DEM file, but I do have a raster image file, and I have a shape file as well. So when I'm connecting to data, all I do is select the type of data provider that I have on the left-hand side, and then on the right-hand side, I decide if I want to add one file at a time by clicking the File option, or if I have an entire directory full of images that I want to connect all of those images, I can actually click on the Folder option and just go and browse to the folder that all of those images are in. Of course, they would all need to be in the same place, and you'd want all their world files in the same place as well. I happen to have just one file, so I'm going to go ahead and grab it. And let me just quickly show you what I have available here. When I am connecting to my images, you'll notice that I have an image and I have a JGW file. That is a world file. You want to make sure that you have that, because if it recognizes the file that you have, you won't have to manually go in and set the coordinate system. You can just have it automatically assign it. But I wanted you to be familiar that it's more than one file is what I'm working with. So if I go to images, all that shows up here is the image file. The world file doesn't show up in my panel, but I know that it's there, and so I know that I'm safe. Now I'll hit connect. And one thing you want to do is you want to make sure that it recognized that world file. So you can see here's the file that I attached, and then as I scroll to the right, it shows me my coordinate system is unknown. Well, even though I made sure I had a world file, the software isn't recognizing it. So what I'd want to do is I'd want to go back and communicate with the people I got the image file from, or I can open up the world file and see if I can figure out what coordinate system it's in myself. Well, I happen to have gone back and communicated with the people I got it from. And so what I'm going to do is I'm going to manually tell the software what coordinate system it is. So what I've done is I've double-clicked on Unknown, and it's opened up this Edit Spatial Context dialog box. Now I'll select Unknown from the list and choose Edit. This is where I would come in and tell it what coordinate system the image file is in. And notice I have a search bar here that I can actually go in and search for specific coordinate systems. Now I could have typed California in. I happen to know that I want to work in NAT 83, so I've typed in CA 83, and I'll select the coordinate system that image file is in and hit select. Then I'll click OK. And now I'm ready to add it to my map, so I'm going to click Add to Map. Now, if I had multiple images, I could actually tell it to combine all of those images into one layer file and then tell it what I want that image to be called. And so I could tell it main side or aerial or something like that, so that I can have just one layer that I stylize down the road, and I don't have to go in and stylize each one separately. So I'm going to click Add to Map, and I'm just going to minimize the Data Connect panel really quick so that you can see the image file in the background. Now, this is great. I love having the image here, but I want to be able to analyze my data. So I want to actually also connect to my parcel information. So I'm going to go back over my Data Connect tool, and I'm going to attach or connect to a shape file. So I'm going to select Shape Connection and choose Shape. Now, I want you to be familiar again with what I have available to me. So let me show you the files. When you receive shape files, you want to make sure that you grab all of the files that you need. You know, we're so used to having just the AutoCAD DWG file and sharing that with people, but when it comes to GIS data, you also need your PRJ file, which is your projection file. It's like your world file for images. You've got your database file and your index file and some other files here, but you want to make sure that you grab all of these files and that they're all in one location, because everything pulled together is what makes it a GIS. It makes it a geographic information system. The database behind it I could actually use to help me stylize my parcels and show those parcels according to the value if I wanted to. All right, so let me go back over here, and I'm going to go find my property shapefile and open it. When I hit connect this time, it recognized the PRJ file, so you can see the coordinate system is already assigned. I didn't have to communicate that to the software. It found that PRJ file because it was in the same location, and I'm ready to keep moving forward. Now I can go ahead and add it to my map, and I'm going to close my Data Connect panel. Now, like I was saying earlier, when I connect to GIS data, it comes in random. The way it looks, it comes in very random. And so you can see mine came in purple this time. Yesterday when I was testing everything to make sure it was going to work okay on the new Windows operating system that I'm on, it came in blue. And you could be doing this right along with me right now, and it could come in green. But the key is I want you to understand how to go in and stylize that so that you can set it the way you want. So to do that, I am going to make sure I can see my map task pane. And on the Display Manager tab, I'm going to simply double-click on the Properties layer. And what this did when I double-clicked is it brought up the Style Editor. And from here, I can go in and change the style. So I'm going to click on the ellipse next to the style. Everything's coming up on my other monitor. And now I'm going to tell it how I want that to look. You'll notice that I have an outline. I can change the outline style. So rather than being a solid line, maybe I want to make it look a little bit more like a property line. I would choose one that's a little bit different. And I could change the color if I wanted. I think black is going to work out fine. And then, of course, I might want to change the fill area. I don't want purple. In fact, I don't want any fill area. I just want to see the outline of my parcels. So rather than having purple, I'm going to change the fill to have no color at all. Okay? And so I could add additional borders if I wanted to. Let's say I wanted to, let's say this was a road center line. If I were working with a line style, I could add additional line styles and have one that would be the thickness of the road, the right-of-way width, and then I could have another one that represents the center line of the road, and I could have that outer one, or the main one that has the nice thick style. I can have that, look similar to asphalt or concrete, and then the center line I could have a white stripe as if it's the center line of the road, and it will make it look a little bit more like a real road would. But I don't really want to add an additional line here, so I'm just going to delete that. So I have my border, my fill that's set to no color. I'm going to click Apply and close that. And what you'll see is it went ahead and stylized my parcels, and when I hover over it, I can see it looks really nice. Okay? Now, I did say that we could analyze the data, so I want to show you really quick how to theme the data as well. If I click on New Theme, I could come in and tell it what value from the data table behind that I want to use. So, for instance, I might want to see things by different land value. It's telling me what my minimum land value is and what my maximum land value is, and I can tell it how I want to proportion that. Do I want it equal proportioned? Do I want a standard deviation, quantile, jerks, or natural breaks, or individual values? And then, of course, I would set my style ramp as well. Okay, so I can set the value from the beginning to the end, and when I click OK, give it a second to, there it goes. You'll see it went ahead and stylized it, and you can see this parcel that I'm working with, that's a pretty high-value parcel. I want to make sure that that's definitely going to be the parcel we use for our project before I even go send our surveyors out to gather that data. All right. Now, what I'm going to do is I'm just going to do a quick undo here, send it back to the no colors so it looks nice. All right, moving on to the next piece. So the next part is we want to be able to take advantage of existing data. And there's a lot of existing data that already has elevation data assigned to it. It could come from, like I was saying, DEM files. It could come from a database file. I happen to have a shape file that has contours. And this is something that a lot of municipalities already have. In fact, you can go out and search for your local government agencies and find out if any of their GIS data is free. Here in the state of Utah, you can download that information from the AGRC, which is our clearinghouse of all of our GIS data. But you can download that for free and be able to take advantage of it as you're analyzing the project before you even go out and collect anything. So I happen to have vector data that's in a shapefile format, and it has elevation data behind the vectors in a database file. And I'm going to take advantage of that to basically create a civil 3D surface that I can start working with before my surveyors go out. So when you're connecting to a surface data or a shapefile and turning it into a surface, it's a 5-step process. First thing you have to do is set the object options. Tell it you want to create a surface from a shapefile, and then you connect to that shapefile on the Connect to Data option. Then you'll set the schema and coordinates, basically telling it, what coordinate system it's coming from, and then you'll do a geospatial query telling it exactly what information you want it to bring in. You don't have to bring in, like let's say I had the entire state of Utah in a shapefile. Well, I don't have to bring in all of the contours for the entire state of Utah. I could actually query just my project location by doing a window crossing or a point and saying, go out from 150 feet from that point, something like that. And then, of course, you want to map the data. That's where you tell it what column in the database file actually represents the elevations. And then, of course, once you have a surface created, you can actually drape the image onto the surface so that that surface becomes kind of the render material, if you will. And so I'm going to show you how to do all of that. All right, so let me go over into the software again. All right, so I'm going to continue working on this file that I created. This time I want to make sure that I am definitely in the Civil 3D workspace because this is the only place that you can access the option to create a Civil 3D surface from GIS data. And where I'm going to do that is on the Home tab, on the Create Ground panel, I'll choose Surfaces, and that's going to expand my surfaces. There it goes. It's just being slow. Let me try that again. There we go. All right. So here I have the option to create a surface from GIS data. I don't know why that's disconnecting. And so when I select that, it's going to pull up my wizard. And so this wizard is a step-by-step thing. You can't go to the next tab unless you've set everything up on the first tab. So the first thing is I'm going to tell it, of course, I want to create a surface, right? And then I'll want to give that surface a name. So it has the default name format, but I'm going to go ahead and type in GIS surface. And then I want to tell it what style I want to use. These are the Civil 3D styles for surfaces, so I'll choose one that's a background style since this is existing data. Now I'll hit Next. Next thing is I have 3 types of data that I can bring in. I can bring in ArcSDE data, Oracle data, or shape files. I do have a shape file, so I'm going to choose that. And I'm going to go out and tell it where to find that file. Next thing is, you'll notice I can't even hit Next until I log in. That's because both Oracle and ArcSDE are full-on databases, and you have to log into the database to be able to use anything. But when I hit Login for the shape file, it's just going to kick me to the next screen that allows me to then tell it what schema and coordinates to use. So I'm using the coordinate class, the contours feature class, which I brought in. And it's telling me, because it found the PRJ file that was in the same location, it's telling me that it thinks that it's this coordinate system that it's pulling from. If it's incorrect, I can always use the ellipse button to go out and tell it what coordinate system it really is. But this one happens to be correct. Now I'll click Next. And this is where I can define how much of that information I want. If I want to define it by a window, I can choose Window, and then click the Select option, and it's going to take me out to my drawing and allow me to draw a window, and that's all of the information that it would bring across. It's just the area in that window. Now, I don't have to use any one of these options. If I uncheck mark the Define Area of Interest, it would basically allow me to bring in all of the contour files from that shape file without a problem. So because I've uncheck marked that, it's going to bring everything in. Now I'm going to hit Next, and this is where we set the data mapping. In the database file behind that shape file, I have 2 columns of data, the geometry column and my elevation column. So I'm just going to bring in, tell it I want the elevation to match the elevation data, and then I hit Finish. And voila, now I have this Civil 3D surface, and if I take a look at that, you can see it's an actual 3D surface, and I can work with it. Now, if I go back out here, let me just scroll up a little bit. What I have is I do have my surface, and when I select my surface contours, notice that it brings up the Surface Contextual tab in the ribbon. And on the surface tools, I have the option to drape my image. So if I click on Drape Image, it's going to bring up, it's supposed to, oh, hold on, I think it's hiding. Yep, there it is. All right, should have brought up this dialog box. And in this dialog box, I basically tell it what image file to use. I only have one, so I only have to choose the main site. And then what surface do I want it to be draped on? Again, I only have one. And then it's going to basically assign that as render material. When I click OK, it's going to drape that image. Now, from the plan view, it doesn't look any different. But when I select that surface and I go to the Object Viewer, I change this to a realistic, you'll notice that now my image has been draped on that surface, and when I zoom in, it looks like the road is actually at an elevation. So it makes it really easy to see what's really going on that surface as if you were on the site physically. So it's a great tool to help you plan your projects and get the information you need to start working with the file before your surveyors ever step foot on the project site, thus saving you time, saving you money, and helping you reduce the cost, the project cost. So just to recap, what we covered today is we have identified where the tools are found inside the Planning and Analysis workspace. We set the coordinate system for a new file, and then we displayed the current conditions by connecting to GIS data, and we created a surface file, or a surface from the shape file containing elevation information. So if you enjoyed the lesson today, again, that came from the Civil 3D 2014 for Surveyors book. That was Chapter 2. That book does come in 2 formats. It's typically a 2-day course if you're taking it professionally. But there's other courses that would help you as well. The Map 3D course, of course, would go in much more in-depth into that planning and analysis workspace to help you be more efficient in planning your projects and analyzing what's happening before you even decide where that project is going to be located. All of our books do come in multiple formats. We have the printed format in a spiral-bound notebook, or we have it in an ebook format that you can see on my screen here. And in addition to that, when you purchase our books, all of the chapters, at the end of the chapters, there are chapter review questions to help you reinforce what you're learning. And if you wanted to know the answers to those questions, of course, you could purchase the instructor tools separately to be able to gain the answers to those, as well as a format to how long each section of the course would take to go through it in an instructor-led course. So thank you, everyone, for joining.